Okay, hello everybody. So I'm Clyde Webster. I'm the founder and managing director of Crest Robotics. I thought I'd take an opportunity in this presentation not only introduce my company, but just myself, to the space community, especially here in Australia. I don't know how many people we have from abroad on the channel, but definitely it's a pleasure to meet you all.
There will be when the YouTube gets up.
Sure, great.
It'll be put up on YouTube.
Yeah, excellent. Wanted to confirm that, yep, Raj still hasn't bought space arms off me. I've been trying ever since, for a few years now, and I'll get them eventually. We just got to find those contracts to deorbit some stuff. I did talk to Clear Space though at the IAC, which is some interesting things to say. So this is me, um, you know, engineer through and through. Been tech my whole sort of career so far, save the last 2.5 years when I decided to start my own business. Idiot, now I've actually got to do work instead of just build things. Engineering background, PhD in robotics specifically. Done a lot of nature-inspired robotics, looking at the world and world around us and trying to discern how these things that existed and how we can utilize what we learned from looking at nature and apply that in robotics. Um, so a few firsts through my career so far. Actually going to go through a few examples. I won't list them all, but I've had a bit of a background in the space sector so far, and I'm continuing that with my company, Crest Robotics. So a bit of a background, first car in New South Wales, electric race car in New South Wales back in my undergrad. Also so I led this team. I was the team leader of about 30 people to build this race car. First team to ever that I know of that tried electric car and actually got into competition in the first year. So that was one of my first firsts, which was really fun. My PhD, I built parrot-inspired climbing robots. So 3 limbs. Everyone knows parrots use their beak to both climb and manipulate the world around us. I thought that was fascinating. And I spent 3 months in a cage videoing cockatiels trying to learn their secrets. They're not particularly chatty about their secrets. They're really just trying to get away from me. But I applied the lessons learned to try to develop climbing robots that could scale tall infrastructure and do maintenance operations. Because what we're trying to do is actually make infrastructure maintenance cheaper in society generally. And that began my journey into robotics and actually into space. So I never thought space sector was something I'd get into. As an Australian, like I didn't really know it existed, to be frank, until my PhD supervisor, when I was looking for some advice on this project, introduced me to a guy called Will Reed, who's a robotics technologist at NASA JPL, and it was one of my supervisor's previous students. And after an hour of talking to him about my technical problems, he said, "So, would you like a job? You could come work with me at JPL for a bit, just as a visiting researcher." And I was like, JPL, I've heard of that in the movies. That sounds really good. I let it sit for 2 weeks to play it cool, but I took him up on that opportunity and got to spend 6 months at NASA JPL studying rover mobility, trying to understand form and function in robotic system design, which is exactly what I did in my PhD with robotics, trying to answer the question of what rover's best, especially for traversing permanently shattered regions of the moon, because we want to go there to explore. There's whispers of volatiles and stuff there we want to extract for human habitation. And so I spent 6 months with JPL just trying to figure out, well, what sort of rover was best, and we spent a long time simulating lots of different kinds of rover suspension and comparing them and asking this very, very broad question about how we go about suspension design. Funnily enough, the 6 wheels you see on Mars, they keep doing that because it keeps working, and that's about it. They're just like, well, it worked last time, so let's just keep doing that again. There's actually, yeah. So we decided to take a step back and sort of build that again from first principles to see if the answer truly was 6 wheels. Turns out there's a lot of benefits to actually 4 wheels on the moon from an energy expenditure perspective, but otherwise, as in all good research, the general conclusion was needs more research to continue. So that's what we did at JPL. When Raj found me at Tech Lab doing my work with JPL remotely, because this was in the middle of COVID lockdowns, he said, "Oh, what do you do?" And I said, "Oh, robotics, and I'm working for NASA." And he was like, "Oh, really? I own a space company." And that's how I wound up being the lead assembly integration test engineer at the Space Machines company, which I did for about 2 years. So this is me with the Optimus spacecraft. So I also designed and built the room that we were standing in, as well as helped design all the assembly and integration procedures for the spacecraft, as well as um, helped design quite a few components on the spacecraft itself as well. So that was a really, really exciting journey. and I'm forever grateful for Raj for giving me that opportunity. I unfortunately left the company about 6 months before launch. Launch kept getting delayed, as they always do in this sector. And I'd always said, look, after I finish my PhD, I'm starting my own company. I've got a vision for robotics in the future and what we can do with it, and I'm going to pursue it. So I did come back and help with some final integration and assembly steps after that. But yeah, 2 weeks after submitting my dissertation, I started my own company, Crest Robotics. And so I'll take a little break to tell you what Crest Robotics is and does. So my vision for robotics, it's all about reducing injury, making dangerous jobs safer using robotics. We've always wanted robots to take out that labor component. And I say robotics as tools and assistance for people to do that. And nowhere is more dangerous than in space. So we want to sell a robot to everyone on the planet, sorry, every tradesperson on the planet, and every tradesperson in space too, because we're going to need a lot of those people as we go and try to live on the moon. You know, people that actually can use their hands, can fix things, can build things. You know, if we're going to maintain a permanent presence, we're going to need people, engineers, technicians, scientists, doctors, to maintain ourselves while we get up there. And so we want robotic assistants that can help in these. So this was the first thing we actually had success with as a company. This is the Gorilla robotic puller. So the bogie suspension here in the middle is actually inspired by my time studying bogie suspension for lunar rovers. And that's given this robot the unique capability to get over obstacles on lines. Nothing else in the market can do that, which is actually enabling new work methods that are safer and faster, so we can, you know, maintain and upgrade our existing energy infrastructure. So Transgrid have some really nice stories about how we've brought space technology back to Earth and applied that, the tools that they're actively using here on the ground. Now, another little bit of a jump. How do we build a lunar base? Why did I start thinking about this? So we have a lot of partners, a lot of different sectors. Construction is a big one, right? So we're trying to do tools for tradespeople. Construction is the biggest sector out there for us. Now, a grant opportunity came up with the New South Wales government, the Space Plus program. It was $500,000 to basically do something, plant a seed, you know, that we could launch at the IAC, the International Astronautical Congress that we just had, to grow something big. And I was partnered with a company called Earth Built Technology at the time. We were considering a new construction methodology based on a technique called earth bagging, which is where you take raw materials that you've harvested from your site, put it in a bag, and basically laid it down, compressed it to form structural layers of a building. So it came out of sort of World War I, sort of sandbag bunkers, that sort of stuff. And it's become slowly more refined over the years to become a technique called earth bagging. On the moon, we call it regolith bagging or moon bagging. I don't think there's an official name yet, but it's been studied in the research for about the last 30 years or so. People have been considering this technology for lunar infrastructure and lunar shelters. And so I was partnered with this company. This grant opportunity came up. I said, look, we are trying to do dynamic robots, do these sort of technologies in the space sector. And this is an amazing opportunity for us to partner up and actually drive this vision. Or how are we going to do this stuff in space? And that's where we came up with Project Charlotte and our vision for early exploration to build shelters and habitats for initial supplies, initial vehicles, initial equipment. Because if we are looking at a sustained human presence on the moon, what we need is longevity. And for longevity, we need a bit of shelter, honestly, from the extremes of the lunar day and night, from extreme radiation. And we're also looking for ways to mitigate dust. And so putting lunar regolith in bags to help make things like roadways, you know, to prevent dust kicking up, is one of the many sort of applications we're looking at for early applications. Now, bit of an artistic render of what a shelter would look like, but it sort of tells the story. And so we went about developing this robot we call Charlotte, which not only will be useful on the moon, but also for sustainable building construction here on Earth, because earth bagging did start here on Earth. You can use the materials around you. It's extremely sustainable. And so we are developing this as a viable technology for construction here to help with our housing and productivity issues. Just to mute that. But here it is being launched at the International Nautical Congress. It's a very generous size. And really our robot sort of stood up, showed the world of the lives. And yeah, it was a really successful week. We spent 9 months developing this. So from concept to giant standing robot in 9 months. And it was a genuine we're really happy with how it performed at the actual conference. There it is. Yeah, we'll go on. Oh no, that's the end of my slide. So next, actually, I was going to do a next. We signed a bunch of letters at the IAC, notably with Intuitive Machines, iSpace, HDR, Icon, a lot of major players that are delivering stuff to the moon and trying to build infrastructure on there. And we are trying to build a vision for what's next. So there's a bunch of smaller things. So iSpace, for example, what we're looking at doing is studies on how more versatile lunar landers can affect the business of delivering stuff to the moon. So for example, lunar landers at the moment can handle sort of 2 to 3 degrees of surface inclination. Otherwise, they're like, no, that's not a landing site, right? That's not very much. 2 to 3 degrees, you'd probably eyeball that and go, that's flat. It's not very much, right? Big rock, no, none of that. Now, one thing we're trying to enable for lunar landers with large active legs is the ability to land on 20 to 30 degree inclinations, right? Really steep stuff. With active control and large, force controlled legs, we can actually open up the lunar terrain and land in a much, much bigger set of places, essentially. So instead of having to send rovers out hundreds of kilometers to get to your site where there's scientific exploration to have, you can land almost on it or near it. And so that's work we're doing at the moment. So taking the same technology we've done with Charlotte and trying to do some of these research projects with local universities and answer these questions of, well, what if I enabled these capabilities? What merit would that give scientifically and from a business perspective to companies that are commercial lunar payload service providers? Another one is exploration. So this is something we're trying to get on the table at the moment, is legged exploration actually has the potential to be, or one we know it can get more places on the moon if you're trying to explore it. Legs are just generally more versatile from a locomotive perspective. But from an energy expender perspective, there's actually merit to using legs on the moon as well. Because a lot of your energy is expended on the moon just picking up regolith, just turning sand. It's kind of like trying to ride your bike in the sand. It's really, really hard. You're spending a lot of your energy just like moving it and not going anywhere. And this really came out of my time studying this exact topic at NASA JPL and doing quite high fidelity simulations with, models of lunar regolith. Now, with a legged machine and large foot pads, we can actually not move much sand at all as we explore. So we can both be more energy efficient, we can be more versatile in our gaits, we can kind of just hop, so we can be faster, and we can access more areas, which has more scientific merit, right? If we can access more areas, we can do more science, we can do more exploration. So this underlying technology that's gone into this actually has a really versatile set of behaviors. And we're currently in the early stages of exploring that with those partners that we've signed on. So that's who we are. That's what we're doing. Sorry, I jump around a little bit in my story, but thank you very much.
I have a question.
Yeah.
So are you really excited to see what Charlotte does in the moon's gravity? Is that
Yeah, it could it's most of the load.
It's hard to visualize because nobody's done that.
Yeah, no, not really. So NASA did do a bunch of work on sort of large legged rovers for moving stuff around the moon. The athlete rover was this, but it's a bit different in its underlying sort of physical principles. So yeah, giant spider robot that jumps around the moon. Only Australia could do that.
What are those really cute little spiders, the little jumping spiders that are Australian?
Yeah, we usually just call them jumping spiders. Yeah, they're adorable. Yeah.
Quite a good question. Thank you for
Yeah.
completely fascinating. You seem to be a fan of lunar rovers having 6 wheels. So I couldn't help but notice that Charlotte has 6 legs. And I was just wondering, does the engineering calculation yield 6 legs as sort of the optimal solution rather than 4?
So it's not so much a calculation thing as me working through the logical steps. So Charlotte needs 6 legs. Well, first it needs legs. So we'll start with why it needs legs. So it needs legs so it can navigate and step over really tall buildings as it 3D prints them. So it's got this extrusion technology at its core. It's going to maintain the position of the body as it moves this extruder element to create these layers. And so to navigate itself around really tall walls, it needs to be able to step over them. It really needs to be able to move legs. Now, 4 is not quite enough to maintain stability whilst you're moving 1 or 2 legs. And if you're trying to maintain really good tracking of the body, so we simply add a few more. We can maintain, sort of 4 points of contact to maintain good stability of the body as we step over walls and as we navigate really complex terrain.
Right.
Yeah. Yeah, it's interesting. The rocker bogey, the typical one, what that suspension geometry does is give you, if you have a sort of a pivot point, you kind of emulate the effect of a really big wheel, right? So if you've got a wheel and a pivot point over here, it's like it rolls over things, and that emulates a really big wheel, which helps you get over obstacles. And so it pushes you closer towards legs, having that suspension configuration, which is quite interesting.
So you seem to have sort of got to the same engineering solution, evolution maps with its insects.
Yeah, probably for different reasons. Evolution's a very random process, but yeah, we just kind of we just try to take it step by step.
There's a couple of that. There's one above the one that's there.
Let me make the window a bit bigger if I can. Nope, that's not going to work for me. Oh, there it is. What do you have set up to power the umbilical? Have you considered any wireless power transmission? Yes. So we haven't actually started developing the power systems for a space application, but certainly when I think about the vision for it, power is something we have to have kind of enabled. If we're going to do any major like civil infrastructure operations, if we're going to be moving anything of significant weight, power needs to be almost the first thing that's sorted. So I sort of always expected that we're going to, Rolls-Royce have been working on their nuclear container for power, and then laser power transfer certainly is the thing that excites me the most. NASA are looking at that, have been looking at that for exploration into permanently shadowed regions where they have laser relays at the top of the craters, so they can laser in power as those rovers go down inside those areas without sunlight. So I do think it's a very promising technology for these sorts of applications. What else? Anything to do with Charlotte's Web? Perhaps. For legal reasons, I'll just say it's a very lovely name for a big spider robot that builds its own house.
Yeah.
Yes.
I don't think eating.
Who knows? I don't want to find out.
I'm pretty sure it's out.
What do you with regards to the lunar application? What are you using as the bags?
So we haven't.
If you want in situ, do you bring in your own bag?
So I can tell you the first bags we'll have to take with us.
Yeah.
And I don't know what they're going to be just yet. Eventually, though, we want to make our own bags out of the material that's there, and that's where a technology called moon fiber, which has been in development for a while, could be really promising. So moon fiber is essentially where you get regolith, you melt it using lasers, and you extrude out a long string out of the fiber. It's very, sorry?
Like a spider web?
Almost. It's actually really similar to basalt fiber. So we do this on Earth with basalt. You can make fabric out of rock by melting it down into really strong fibers and weaving it into fabric. And it is, sustainable. Well, it's a lot of energy, but it's extremely heat resistant and robust and high tensile strength material. So it's actually be perfect for bags. It'll be perfect for launch pads. Right, it's melted rock, so it's 1200 degrees centigrade, sort of like resistant. It's really incredible stuff. That's eventually what I want it to be.
Be a very useful heat shield.
Oh yeah, it's amazing. And regolith, once you pack regolith behind it, regolith has pretty poor thermal transfer properties, so it insulates quite well. So a bit of basalt or moon fiber bag and some regolith would actually be an incredible heat shield. And it doesn't. Yeah, I don't think it ablates. Don't take my word for that though. It can also store. One thing I'm really interested in the way we build structures is working with some researchers to understand how we can use the bag and the sort of insulative properties of regolith as a bit of a thermal battery, right? Because we want to sort of, when equipment's on the inside, what we're trying to do is really remove the extreme ends of the temperature fluctuations. So if we have a bit of a thermal battery that can emit energy internally, then we can keep things, I'm not going to say warm, it's probably still going to be negative 80 plus minus. It's still going to be really cold, but by machine design standard, it's not going to be negative 200 and something. When you say lunar adaptable robots are energy efficient and are made in a way not to move sand for more exploration to have, what implications has to be applied to make it applicable? And is Crest Robotics is based on intuitive machines? Sorry, give me a sec. When you say lunar double. So I mean, from energy efficiency, I mean from a cost of transport perspective. You know, in terms of energy spent to move the machine around, we're trying to minimize that energy expenditure because energy is going to be a real resource on the moon, and we don't want to waste it sort of just moving regolith around in the wheels of rovers. It also enables a rover to be more resistant to dust. You know, the rotating components on lunar rovers are some of the hardest designed to be dust mitigation, dust resistant. Now with a legged robot with really long legs, I can actually just put it in a spacesuit. So I could just cover all the joints, basically just protect it from dust, how we protect ourselves from dust, which is a big flexible spacesuit. So there's no exposed rotating components at all. And then we don't actually have to be down in the dust as much as well. So there's potentials for high energy efficiency, good dust resilience, and then really versatile locomotion with the legged platform on the moon, which is why I think it's a really promising technology. So I didn't really understand what the second part of that question means. If you want to clarify, I'd be happy to answer that.
Yeah, like you mentioned that intuitive machines and all like different longevity is coming up in your it's like the advanced methods which you would be using ahead. So I was just curious, is that was also applied in the robot Crest robot, which you were being just discussing just before?
Sure, yeah, absolutely. So what we're trying to do with intuitive machines is essentially get a payload on one of their rovers. Funnily enough, all the commercial lunar payload service providers are really interested in is more payloads for their landers. That is their primary business interest. And we are more than happy to try and participate where we can, because there's huge opportunity for Australia to really, you know, get behind technologies that can make us unique, make us, you know, really cement our role in the Australians, in the international space economy. And I really think there's a chance that giant spiders is something we can sell to the world, or, you know, nobody's going to do it but us. You know, I saw a South China Post just did like Reuters did a whole article from us, and the first comment is, of course it's Australia. Of course it's Australia doing the giant spider robots. But there are genuine scientific reasons that this sort of technology can be the best for these sort of applications. And if we factor in or layer in sort of infrastructure creation, which is something that Australians are really good at, you know, we have more infrastructure per capita than anywhere else in the world. We spend way too much money on it. If we can invest in technologies that can use more local materials, that are more sustainable, that can make infrastructure creation cheaper here on Earth, and we can fund that as part of going to space, then I think we can have a real shot at an identity, I think, in the international space community that makes a lot of sense. Yeah.
I think I remember you telling me earlier that you had a state government contract or something to do some of this work, so you'll actually be doing some of the testing on Earth first.
Oh, all the testing will happen on Earth first.
No, I thought specifically was building something.
Yeah, so all our funds with the whole program so far has been supported by the New South Wales government. So that funding, we've spent it all now, and now we're looking for the next steps, really. We're looking for how we're going to fund it going forward. But certainly those connections with the government mean we can hopefully get some really interesting government projects.
That's really cool. So are you working with AMRF as well, or are those things, or is everything manufactured in-house?
We're not working with AMRF just yet.
Okay.
I am due a visit out to the AMRF facility. I've heard it's very good. I actually think they could use an in-house robotics capability to tell them how and where to spend money on what particular machines are manufactured, because they've got all these great machines, right?
Yeah.
But what they need is more in-house to be like, well, this is where and when, and you should use stuff, and bundle manufacturing into a bigger engineering capability is what I think we should do. Anyway, I owe them a visit because I haven't been out there yet. Certainly I need more space. The giant spider robot literally takes up half my office. I can't make a walk in there. It's much too small. They do have a bunch of space out there. I would love to be out there and close to that facility. I think there's another one. Are you able to reveal source of funding? Yes, I think I just did. So New South Wales government funded this part of the program. Otherwise, as a company, I've been entirely funded by sales and sales grants. That's it. So fully bootstrapped so far. I haven't taken a cent of investment. Going to keep trying to do that if I can, but always open to investors that do want to, you know, reach out. We got a lot of money to spend and a lot of opportunity to exploit. But yeah, that's all just bootstrapped so far. Just a thought, hybrid Charlotte, wheels attached. Now, my initial Charlotte concept did actually have wheels attached, but then I was looking at the budget we had to develop it, and I said, if we have wheels, that's more motors, and we have to, control the direction of those wheels. That's more motors again. So we're talking 12 additional degrees of freedom that are technically redundant, right? I can move in the way I need to without them. And so it just adds expense, adds complexity, adds potential failure points for not much gain, right? It maybe is a little bit more energy efficient here on Earth. On the moon, it likely wouldn't be because of all the energy that's spent just turning up regolith with wheels.
But I was going to make the point that so far you've worked on the motion, basically, of the robot, rather than making something with it, as in the actual structures.
Yep.
You mentioned the bags, which sounds neat, but do you really have to go with the bag approach? Wouldn't you like to be able to just scoop up some regolith, or for that matter, some soil here on Earth, and then sinter it or melt it slightly? Wouldn't that be that's a different approach, and you might argue it's something you could try out a lot.
I'm so happy to try pretty much anything with Charlotte, and we have also been developing the actual printing extruder technology. I can't show it because it's not our IP. It is owned by Earthbuilt, and so I can't disclose any of that yet. But we have that technology. Now, the sintering approach, I would argue, embodies a lot more energy, typically. And going back to the sort of general principles that energy is going to be a premium, even going to be a currency almost on the moon, I would expect. Minimizing energy expenditure for these sort of structures is something that I think is likely going to be in our best interest.
That's why the encapsulation approach works better, perhaps.
And definitely in the early days when energy infrastructure is still being set up, bringing the bags with us as one of those few critical materials we bring with us is likely to be the case, right? I suspect. Can help with the housing crisis? Yes, it can, or it will be able to. That's exactly, it was the New South Wales government that put up a grant. They haven't historically done a lot of space funding. They've got some amazing programs, obviously. But we wrote the grant around how this technology could be useful back here on Earth, how it could help with assisting the housing crisis here on Earth, because it's a government. They've got their priorities, and you've got to be sensitive to those as you write those narratives. And I do suspect that's a large part of why we run the grant. But also from a business perspective, not a lot of people are paying for lunar houses just yet. And when I say not a lot, I mean no one. No one's paying for lunar houses just yet, right?
We pay for one free.
I think you can live with the spiders, I think, yeah. So yes, we very much see this as a terrestrial technology with a vision for where it could be used on the moon. But we're trying to make houses, or at least, just the walls at the very least, something that's very cost effective, something that's very sustainable, and something that can be constructed in sort of 24 hours for the walls of the house, with a full 3D scan, millimeter precise scan, because the robot needs to do that just as part of its being, of the house. So you can start getting factory made trusses and other components for it sort of shipped in and installed is kind of the vision we have for it. That's more on the Earth-built technology side. Their business is the Earth-built housing side. Mine is really the robotics. So it's partnership. It's partnership for the terrestrial application. Cool. All right. Well, thank you all very much for those that joined in line. And thank you everyone here.